So we subtract 5. We would add 5 to both sides. So we have x is less than 13. And that's our answer. Peter, what did you do for number 2? So we could subtract 3x. It would be easier though to subtract 1 first. So we have 3x is less than x minus 1. And then we can subtract x from both sides. And we get 2x is less than negative 1. And then what do you do from here, Peter? How would we get the x all by itself? Right now it's being multiplied by 2. So how would we get rid of that? Divide. So we would divide both sides by 2, and we get x is less than negative 1/2. Dylan, what did you get for number 3?
I got
y is equal to 18. We got that by dividing both sides by 5. Perfect. Sophia, what did you get for number 4? This is Sophia.
I did minus 15.
So you subtract 15 from both sides, and we get 5x is equal to 75. And then what do? So we divide both sides by 5 and get x is equal to 15. So that's a warm-up, just a little bit of an algebra review. So the objective of 3.4 is to prove and apply theorems about perpendicular lines. The vocab is perpendicular bisector and distance from a point to a line. So first we're going to take a look at the vocab. The perpendicular bisector of a segment is a line perpendicular to a segment at the segment's midpoint. So what does it mean to be perpendicular?
Cross.
They intersect at what? At what? What would be the angle that they intersect at? To be perpendicular means that they intersect at we're just looking at the word perpendicular. We went over perpendicular lines yesterday, or Friday. So perpendicular lines intersect, they intersect at a point, but what type of angle are we talking about? A 90-degree angle. So perpendicular means that they intersect at 90 degrees. And bisector, what does the word bisector mean? Cuts in half. So the left side would be equal to the right side. So that's what a perpendicular bisector is. Next, we have the shortest segment from a point to a line is perpendicular to the line. This fact is used to define the distance from a point to a line as the length of the perpendicular segment from the point to the line. So if we have a point and if we have a line, the closest distance from this point to the line will be perpendicular to the line. So this will be the shortest length. If we had a line going this way, this length will still be shorter. The one that's perpendicular will be the shortest length from the point to the line. So that's the shortest segment. So we're going to go over some examples on the next page. Name the shortest segment from point A to BC. PA, yep. So segment PA, would be the shortest segment from point A to line BC. This segment right here. Next, write and solve an inequality for x. So what do inequalities have to have? Less than or equal to. So inequalities have less than or greater than or less than equal to, one of these. So what would this inequality look like? How would we set up this equation as an inequality? Greater than, what's it greater than? 12. How would we know that x minus 8 is greater than 12? Because 12 is going to be the shortest line, so x minus 8 has to be greater than the 12. So now we solve for x. So Florencia, how do we solve for x? We add 8 to both sides. So we get x is greater than 20. And that's it. That's all we do. Let's look at another example. Name the shortest segment from point A to line BC. Alexis, what would our shortest segment be? BA, perfect. So the shortest segment is the one that's perpendicular to the line. Now write and solve an inequality for x. X minus 5 is less than 12. Perfect. Because we know x minus 5 is going to be our shortest segment, so every other segment has to be bigger. So x minus 5 is less than 12. Bless you.
Thank you.
Ian, how would we solve for x here? We would do the same thing as if this was an equal sign. So how do we get x all by itself?
You add 5 to 12.
So we add 5 to both sides. So these would cancel out. We get x is less than 17. Perfect. So there's 3 theorems that go along with perpendicular lines. The first one, if 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So if we have 2 intersecting lines, and these 2 angles are congruent, so this linear pair forms 2 congruent angles, what would each of these angles have to be? They're congruent, but what's their measure? Why are they 90? Because they form a straight line. So if the straight line is 180 degrees, and these 2 are congruent, then both of them would have to be 90. So if 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So therefore these lines would be perpendicular. So L is perpendicular to M. Remember, this is the sign for perpendicular, the upside down T. The next theorem we have is the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So if we know that the transversal is perpendicular to the top line N, what would this angle here have to be? 90. What about its alternate interior angle? What would this one have to be? 90 also. So right now we just proved that this line is perpendicular also. So if the transversal is perpendicular to one of the parallel lines, it has to be perpendicular to both of them. That's the perpendicular transversal theorem. And lastly, we have if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So this is the same thing as the one before, but just reverse. If we know that this line is perpendicular to both of them, then we have to know that these two lines are parallel. Now we're going to do some proofs involving these theorems. This is what we would write. Two intersecting lines form linear pair of congruent angles, then the lines are perpendicular. So given that R is parallel to S and angle 1 is congruent to angle 2, how would we prove that R is perpendicular to T? So looking at this, we know that 1 is congruent to 2. How do we know what angle 3 is?
Yes.
What is it?
Same thing.
It's the same thing as what?
90.
We don't know it's 90 yet. What do we know that angle 3 is equal to?
Same thing as 1. And
It would be the same thing as 2 because why? What are 3 and 2?
X. And 2.
Corresponding. So 2 and 3 are corresponding. So we have angle 2 is congruent to angle 3. Why? Because they're corresponding angles. Now step 3 says we're going to use the transverse property of congruence. So looking at steps 1 and 2, using the transverse property, what would we come up with for step 3? So looking at step 1 and 2, we have a 2 here and a 2 here. So then what do we know about the other two angles? So then we can say angle 1 is congruent to angle 3. That's the transverse property.
Can't you just flip it with 3 and 2?
What do you mean?
Like just put angle 3 is equal to angle 2.
Well, here we said that angle 2 is congruent to angle 3. If we said angle 3 is congruent to 2, it would just be like restating the same thing. But we could use a transverse property, or we could use substitution here and to say that angle 1 is congruent to angle 3. Yes. So now we know that angle 1 is congruent to angle 3. So going back to the page before with all the theorems, what would be our reason for 4? So if you go back to the page before, is it the first, second, or third theorem on that page?
The first?
It's the first. So this would be two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Unfortunately, this theorem doesn't have a name, so we're just writing down what's going on. So if we go back to the page before, it says, so we came up with that the lines are perpendicular because the two intersecting lines form a linear pair of congruent angles. On your quiz, we're not going to have any proofs. So you won't have anything like this. But it's just good for you to know, and you'll have questions like this in the homework. Okay, let's look at the next one. So angle EHF is congruent to HFG, and that's given. So we have this is congruent to this. If we're looking at line EH and line FG, and this is our transversal, what do we know about the alternate interior angles? What is this telling us? The alternate interior angles, so this one and this one. They're congruent. So if we know that the alternate interior angles are congruent, then we can say that these lines are parallel. So EH is parallel to FG. So for step 2, we can write, because alternate interior angles are congruent. Next we have line FG is perpendicular to GH. So these two lines are perpendicular. They gave us the little box. So if we know that this is perpendicular and these two lines are parallel, then what do we know about this angle here, this whole angle here? What is it? What would be the measure of it? 90. So this would be perpendicular too. And what would be the theorem from the page, 2 pages before, that told us that this was perpendicular also? Perpendicular transversal theorem. So if a transversal is perpendicular to one of the two parallel lines, then it's perpendicular to the other. So this is the perpendicular transversal theorem. Write and solve an inequality for x. 2x minus 3 is less than 25. Perfect. Haley, how would we solve this? So we would add 3 to both sides. We get 2x is less than 28. Haley, what would we do next? Divide both sides by 2. And we get x is less than 14. Yes. That's our answer. So now let's look at number 2. Solve to find x and y in the diagram. So first let's take a look at 10x. What do we know 10x has to be? Congruent to what? It's congruent to that, but what's the number that we know automatically what this equals? 90. So we can say 10x is equal to 90. Then what would x equal? 9. So now we can take this x is equal to 9, plug it into this equation. That way we only have one variable. So what's 8 times 9? 72 plus 4y. So Sam, what do we know that this equation equals? It equals 10x, but what was the number that we can set this equal to? 90. So 72 plus 4y is equal to 90. So now we need to solve for y. Sophia Silvestre, how do we solve for y? So we get 4y is equal to 18. And then we divide by 4. Perfect. So we get y is equal to 4.5. So we found x and we found y. Okay, last slide. Complete the 2-column proof below. So we're given that angle 1 is congruent to angle 2 and P is perpendicular to Q. So we know angle 1 is congruent to angle 2. What do we know that 2 is equal to? 90, because its vertical angle is 90. Then, so if 2 is 90, then what's 1? 90 also. So this says Q is parallel to R. If both of these are 90 degrees, they're equal. So what do we know about the two lines? What would the two lines be? The lines, this one and this one, what would they be? The lines are parallel. So we know that Q is parallel to R. Sam, how did we know that Q is parallel to R? Sam Higney. You just said it. Corresponding, because the corresponding angles are congruent, so then the lines are parallel. So this is because corresponding angles are congruent. So P is perpendicular to Q. And now we know that P is perpendicular to R. So the perpendicular transversal theorem. Perfect. That's 3.4.